I mentioned in class these work application problems where you have two people working on that individually, they do a project, a task, and it takes the first person this many hours, and it takes the second person a different speed, a different number of hours, different length of time to do that. When you combine them and they can work together, how fast can they, should be even faster, how long does that take? Here's the way to think about that. So in this example we talked in class, we've got printing presses that are printing 1,000 magazines or some huge number of magazines for this company. Printing press 1 takes 6 hours to do the whole job, where printing press 2 takes 12 hours to do the whole job. It's a slower machine. If they're working together, how long will it take? Here's the way to visualize that and think about that problem. Because you can't take 6 hours and 12 hours and average them, because you want your answer to be faster than the one working by itself. The second machine should help it go faster. So it should be less than 6 hours when you're done. How do you figure that out? Think about, instead of taking 6 hours to do the job, think about in 1 hour, it can do 1/6 of the job, right? Divide your entire work into 6 parts. It can do 1/6 of the job, or 1/6 of the magazine, or 1/6 of the whatever the context is in 1 hour. What about the printing press 2? It can do 1/12 of the job in 1 hour. That's this little spot down here. The big blue box is supposed to be the entire job, the entire stack of magazines. So if they're working together, side by side, not interfering with each other, how much can they do together? Well, I can add those up. And in 1 hour, it can do 1/6 of the job plus 1/12 of the job. So those two fractions added together. On the other hand, think about this over here in the purple. Combined, we want to know it takes X hours overall to do the entire job. So it can do 1/x of the job in 1 hour, 1 over X. So I have 2 ways to calculate what fraction of the entire job these two machines can do in 1 hour. It's one way, it's 1 over 6 plus 1 over 12, and then the other way, it's 1 over X. So set those equal. How much of the job can be done in 1 hour? Printer 1 does 1/6, printer 2 does 1/12. Overall, they do 1x. Solve for x. Multiply by the common denominator, which in our case is 12x. What cancels? The 12 and the 6 cancel to give you 2x. The 12 and the 12 cancel to give you just x. And over here, the x and the x cancel to give you 12. So 3x equals 12, and magically combined, they can do 1/4 of the job in 1 hour. So it takes 4 hours to do the whole job. And you can double check. 1/6 plus 1/12 equals 1/4, because change them all into common denominators of 12s. 2/12 plus 1/12 equals 3/12. Yay, we're done. Here's another example. We're going to mow a golf course, and one guy can do it in 4 hours, and another gardener can mow the same golf course in 6 hours. Okay, so one guy takes 4 hours, the other person takes 6 hours. If they mow together and they don't interfere with each other, how fast can they do it? Here's the visual. You've got this big green golf course right here. This rectangle is all of your golf course. Person on tractor 1 can do 1/4 of it in an hour. Person on tractor 2 can do 1/6 of the course in an hour. So together, they do a total of 1/4 plus 1/6. And if it takes X hours to do the entire course, they can do 1/6, or sorry, 1x in 1 hour. And so again, you can solve for X. In this case, the common denominator is again 12x. 12 is a common example for these because it has lots of common factors. Here we multiply by the 12x times the 1/4 and the 1/6. We get 3x plus 2x equals 12. Solve for x, 5x equals 12. X equals 12/5, which is 2.4 hours. So a little under 2.5 hours to do the job combined, when on their own, it took 4 hours for one guy and 6 hours for the other.